This is pre-calculus, notes on 6.3. And the title of this is arc length. Okay. So, hold on, I'm on the wrong page. Go again. Arc length, there it is, 6.3. All right. So, first of all, we need a definition of what an arc is. Okay, so an arc is a portion of a circle. And the definition of a central angle, an angle whose vertex is at the center of the circle. So here I've got a graphic for you, okay, where I've outlined this in pink right here. This is an arc, okay, and that corresponds to this central angle that's labeled as theta, okay. So the ends of the initial and terminal ray mark the beginning and end of where that arc go, okay? Now, if I wanted to find the length of that arc, okay, which we're going to call its length S, right? What I might want to do is, first of all, find the ratio of whatever that central angle is to the number of degrees in a circle. And of course, there are 360 degrees in a circle. Okay, and once I know that ratio, then if I multiply that by the formula for circumference of a whole circle, okay, so you know that the circumference of a circle is 2 pi r, all right? So if you were to multiply in yellow the ratio of what the central angle to the whole circle is with the circumference of a whole circle, you should have the length of just this pink part, okay? Now, that equation or that formula that we've just come up with on our own there is not in simplest form, okay? But if you were to put this in simplest form, you can cancel a 2 out of top and bottom. Okay, and then do top times top, and theta times 2 pi r is 2 pi r theta, okay, and on the denominator, I've got 180, and then I canceled this 2. Why did I put this 2 here? So my formula for arc length is pi r theta divided by 180. Okay, what do I have over here? The formula for arc length where theta is measured in degrees is S equals theta times pi times r divided by 180. All right, now let's move on to this. Okay, this is really, really important because we're going to take what I learned in this section, I'm going to apply it towards the next, right? So now what I want to do is I want to consider a special case. I want to consider a case where I've got a circle whose radius, oops, I thought I was using highlighter there. Okay, whose radius equals whatever the arc length is, okay? So no matter what that radius is, if we just take that little portion of the circle where the radius is equal to the arc, okay, well, what would be the measure of theta that would give us that arc, okay, where radius is equal to its length? All right, so in this picture, I have marked both the radius and the arc length S, okay? They're all supposed to be the same. Well, if that's the case, what's the measure of angle theta? So I am going to take this formula that I derived on the previous page, okay, and where S is, okay, I am going to put an R. So I've got R equals theta pi r over 180. I'm going to find what theta is. So let's multiply by 180. Okay, so I've got 180r equals theta pi, and of course 180 cancels, theta pi r. Okay, trying to get theta all by itself now, so I'm going to divide both sides by, well, I'm trying to get rid of this much, I'm trying to get rid of theta pi, I'm going to divide both sides by, oh my god, Paterno, I can't pay attention. I'm trying to get theta by itself. Let me undo that. Undo that. Okay, I'm trying to get theta by itself, so I want to undo multiply by pi r. Okay, so I'm going to divide both sides by pi r. All right, so pi cancels, r cancels, and r on this side cancels also. And so what I'm left with is 180 over pi equals theta. All right, let me go back and say one more time, well, what's the significance of that? All right, that is the measure of the angle where the radius is equal to the arc length. Okay. So when the radius is equal to the arc length, then theta is equal to 180 degrees divided by pi. If you plug that into a calculator, you find that measure to be about 57.3 degrees. But since pi is irrational, of course that decimal will repeat forever. All right, I hope this video was shorter than the last one. All right, that's it for that video.